Simple definition of a cooling tower. A cooling tower is a heat rejection device which extracts waste heat to the atmosphere through the cooling of a water stream to a lower temperature. Common applications for cooling towers are providing a cooled water for air conditioning, manufacturing, and electric power generation.
Hi, I'm Andrew Maglana and I am here to explain how cooling tower works. Warm water from a heat source such as the steam power plant pumps water to the top of the cooling water. The warm water enters the cooling tower and the water is evenly dispersed to a larger surface area to increase evaporation and removes heat. The large fan located at the top of the cooling tower draws air from this side and this side to increase evaporation and cools water. The water then continues to flow to the tower sump and back to the system to cool the heat source. Wait lang, pause mo muna. As system water evaporates, only pure water is lost. All the elements in the system water remaining a less water volume. To make up to the water that is lost due to evaporation, fresh water is introduced through the makeup line. This fresh water carries additional elements to the system water where they accumulates. The more water that evaporates, the greater the volume of water through the makeup line is needed to replenish the system. Thank you.
Designing cooling towers. In designing cooling towers, there are 5 parameters wherein this combination will define the performance of a cooling tower. 1. Hot water temperature. 2. Cold water temperature. 3. Wet bulb temperature. 4. Water flow rate. And 5. Air flow rate. The first 4 will be given by the user, and the fifth one will be given by the tower designer. Once these 5 data are available, the tower characteristics can be calculated through a Merkel equation. The first step in designing a cooling tower is the generation of a demand curve. In this curve, the values are plotted against the varying ratios. The next step is to superimpose field characteristics curves and demand curves. Cooling tower designing is basically an iterative process. The factors that affect the selection of design, water flow rate, and air flow rate, and consequently the field height are cell dimensions, water loading, air velocities across various cooling tower sections, and pressure drops and fan selection.
If you have trouble in motor stoppage, possible causes: electric blackout, fuse burned out, insufficient switch capacity. Possible solutions are: get proper fuse, change the proper switch, and adjust the contact. If you have trouble in sudden lowering of motor RPM, causes are too heavy loads or lowering of voltage. Possible solutions are lightening the load. If the motor temperature rise, its causes are it's carrying too much load. So the solution is to lightening the load.
If you have problem due to noise and vibration, first you can check the fan mounting if it is loose. If it is loose, you can tighten the mounting bolts of the motor and correct or replace if needed. If fan blocks are loose, tighten blade in hub. If one is unbalanced, rebalance and adjust. And if it cannot be rebalanced and adjust, just you can replace it with a proper one. Motor bearing faulty. Check and grease or replace the bearing on the motor. Hub mounting on the motor shaft. Tighten and use plate and shims if required. Many parts of rubbing against tower component. Give proper clearance and adjust or align components. If you have trouble with water flow above the specified flow, you can correct it by correcting the flow rate. And if you have trouble by having an airflow below specified flow, adjust blade angle of the blade, fan blade, and clean it. When the problem is load higher than the design, adjust load to correct flow rate. And if fields are choked or coated, clean or replace fields. Use proper water quality.
So here's the cooling tower. We're going to explain on how to maintain properly a cooling tower in order for it to work efficiently. Check the makeup water supply for the appropriate water level to conserve water and reduce air entrainment. So this is the machine guard. This is the motor, the propeller, and this is the makeup water tank. Adjust the rate accordingly per your local water quality and evaporation rate regulations, preventing accumulation of solids in the circulating water. Routinely check oil of the motor and the shaft alignment in order to secure its safety and stability. Lubricate fan shafts bearings every 3 months to maintain a proper operation.